Alright, so what I want to do is I want to show you something that I think it's one of the coolest things I've seen in math. And some people would disagree with me in this, and I don't know why I find it so fascinating, but I didn't see this until after college. It's a truth in math that even when I first saw it, I didn't believe it, and you probably won't either. And I'm going to show you some proofs, and it's like, oh my goodness, something so cool. I asked myself, why have I not seen this before? Okay, and in school, sometimes we're so focused on like taking tests, passing tests, that we don't even care so much about, things in math that are not going to be on the test. Okay, so we say, okay, this is not going to be, I'm not going to be tested on this, so why do I care about learning it? Well, the thing is I believe wholeheartedly that the number one thing in education, or at least one of the top things in education, is passion. And a sense of awe when you're studying a subject. When I study math, I sit in awe sometimes of just how complex, beautiful it is. And I don't think people get that. They think of it, as at least my perception, is that people sort of see it as a dry, boring subject. And some people, not all people, and to be honest with you, I've even myself seen it that way. I've always been good at it, but I just saw it as numbers and letters, and sometimes just trying to solve a problem. And when I got into college, I began to see things when I had to prove certain mathematical concepts, or I was shown certain mathematical concepts. And this is not just a dry, boring subject. It has history. It has so much meaning. And you find that most mathematicians were also philosophers, which to me it didn't make sense, because you think mathematicians are just boring people who like to solve problems. But there's so much more to it than that. And my hope is that I can sort of at least give you a taste of that. I heard someone say this, and I thought this was very profound when talking about why students hate math. And he gave the example of like art. So, and I'm not really an artist per se, but when we're in art class or something, they show us the first thing they do is show us great art. So they'll show us, and forgive me, but this is my Mona Lisa with her sideways smile. They'll show us the Mona Lisa, in her picture with, by, Leonardo da Vinci. Then they'll show us this picture, and we'll be like, oh, that's a good picture. And then they'll show us some other paintings or whatever, and they'll say, wow, we'll look at it and we'll go, oh my goodness, that's so good, that's drawn so well. How did they do that? And then we'll see all the greatness in art. And even if we are not good at drawing, or we need a lot of practice to get better, we'll appreciate it. Okay? And a lot of students think that they're not good at math, and I don't even know if I believe that I believe every student can develop the skills in math. But even if you consider yourself not to be quote unquote good at math, okay, you can at least appreciate its beauty. Okay, this is not this is not beauty. Okay, this is not Mona Lisa. I didn't draw. I'm not Leonardo da Vinci, but I can at least appreciate it, even though this is my drawing of Mona Lisa. Okay, and so my hope is you can appreciate it. Okay, and I know I've talked a lot, but here we go. I'm going to talk about one truth, and this is the truth. Where's my red? It's that 1 equals 0.999 repeating. Okay, and forgive me, I'm trying to do this with a mouse. I don't really have the tools here to make this any better. And actually, let me use my finger here. Okay, so I want to talk about the fact that 1 equals 0.99 repeating. And I remember I saw this on the internet, and I thought, but I was like, that's not true. Those two things cannot be equal. And this is someone who was majoring in math, okay, someone who's taking our classes. But I want to show you that this is true. And I want to prove it to you a couple different ways. Okay, so the first way I want to show you is, I don't even know if it's necessary proof, but it kind of gives you an insight into this problem itself. So let's look at 1/3. Okay, and some of you may know what 1/3 equals as a decimal. Okay, if you ever typed it into your calculator, you'll say, okay, that's 0.333. So repeating. Okay, and you just keep going with a bunch of threes. Well, what happens if I multiply both sides of this equation, which remember we're allowed to do without changing its equality, by 3. Well, 3 times 1/3 is just 1. But what's 3 times 0.333 repeating? Well, that would be 0.999 repeating. Okay. Now, and some people would say that this is not really vigorous enough. This is not a proof that, kind of shows enough detail, and it's not really good enough. Okay, so I want to show you one of my favorite proofs of this truth, and I love this because it's more philosophical. I mean, it's mathematical, but it kind of has some philosophical kind of taste to it, and so I want to do that. So the first thing I want to show you is if you're saying that 1, let's go ahead and assume the opposite. So some people will say, well, I don't believe that these two are equal. So they're going to say, yeah, no, that's not equal to each other. Okay. So if we want to show that it's not equal to each other, we need to let's try to prove that. Okay. So if 1 does not equal 0.99 repeating, then what that means is let's go ahead and say let's draw a little timeline here. And I'm going to use white for that. Let's draw a little, not timeline, sorry, a number line. And let's draw 1 here. And then we're going to draw 0.999 repeating. Okay, so if these two numbers are not the same, then there has to be some distance between these two numbers. There has to be. Okay, if there's no distance between these two numbers, then of course they're the same. So let's say this distance we're going to call D. Okay, sounds simple enough. All right. So if there is a distance between, or if these two numbers are not the same, then there has to exist some distance between these two numbers, and we're going to call that D. Okay. But if there's a distance between these two numbers, we could take D, so whatever that distance is, D, and divide it by 2. Which basically means that we can find more distance between these two numbers, meaning there's more numbers here. Okay. In fact, if there is a distance between 0.99 repeating and 1, then there's an infinite amount of distances here. Okay, and this has to do with Zeno's paradox. But if there's any distance between these two numbers, then there has to be an infinite amount of numbers. But what possible number would be between 1 and 0.999 repeating? Well, there can't be a number. Some people say, well, this is like the very next number. Well, if this is the very next number, which is, if this is like the very previous number to 1, we still have to say that there's a distance between these two. And we would have to say that that D is somehow the smallest possible distance. Well, that's not possible, because we can always take a distance and divide it by 2, which means there's an even smaller distance between these two values. And it's not even possible, because we know that there's no way we could fit a number between 0.99 repeating and 1. And so because we can't fit a number between these two numbers, they have to be the same number. Okay, I'm not sure if I explained that well enough, but I'm hoping you kind of get that concept. And the last way would be actually finding the average of these two numbers. And I don't have time. It seems like I've already used up about 9 minutes. And so I'm going to leave it for right here. But I'm going to go ahead on the next video and I'm going to show you the proof using averages. And so if you take the average of these two numbers, you'll find that it gives you an interesting consequence or solution. And so anyway, math is a beautiful subject. It is not dry. It is anything but dry. And my hope is that at least seeing something like this and trying yourself, to me, one of the greatest things in math is trying to prove something. Okay, because when you try to prove something, you begin to actually see the meat in what you're trying to prove. You actually begin to see, okay, what is this? What am I actually dealing with? What are numbers? What are their purpose? And things like that. And so anyway, I hope this kind of intrigued you, gave you a little taste of what math can be, and I'm gonna try to prove it to you later.